Hello, so in this video I'm going to be talking about the TI-nSpire CX Calculator. I'm going to be talking about the engineering behind this calculator and discuss how it's designed. So here are some images. I made 3 images here. On the very left side of the screen there's an image of that calculator I'll be discussing about in this video. Talking about in this video, and it shows like graph of the graph of some sailboats and different equations. It seems like all of these 3 equations, the blue, red, and green one, are linear here. And here, kind of in the middle center um, of the screen, there's on the screen of the calculator. It seems like it's some chemistry stuff, because it seems like there's a mixture here, and there's like some graphs here and stuff like that. As you can see here, it says H2O, H plus, that's a hydrogen ion. Here there's a sodium ion, hydroxides right here. So there's chlorine, so that's it can perform like different chemistry operations as well. And here at the bottom right side of the image, there's like another feature that this calculator can do. It's called 3D graphing. And this calculator can graph images and stuff. Basically, it can make graphs that are in 3D, and that's a pretty interesting feature. Because I'll be, as discussed before, I'll be discussing the engineering behind this calculator, and this feature is pretty difficult to design because it's pretty advanced. So yeah, we'll discuss that later in the video. That's a pretty interesting feature. It's pretty cool. I find it pretty interesting. So first I'll mention some background information, and it's like an introduction to the video. So the TI-nSpire CX, it's a graphing calculator, and it has a long-lasting battery. It also has a colored screen, so it has better graphics, and it has a large memory storage as well. Now I'll discuss some of the technical information about this calculator. First off, I'll start by discussing the processor that is used in this device. The processor for this calculator is an ARM9 CPU. CPU stands for Central Processing Unit. And then the CPU, the ARM9, can function up to 132 megahertz. The CPU, it can has a few like main tasks. It uses up less energy. It has less energy consumption, and also at the same time, it is able to perform complex tasks. And tasks refers to math tasks because this is, as discussed before, a graphing calculator, so it's used for math related stuff. It can be used for some other things like maybe for engineering or maybe some parts of chemistry, physics, but it's mainly for math, though. It's mainly a math calculator. So yeah, it can perform some complex tasks, and at the same time uses, not that much of a significant amount of energy. Now we'll discuss the architecture of the memory components. So I'll discuss the memory that's used for this device, this calculator. So the device has 3 memory components, as 3 of them. First is the NAND flash memory. This is the memory that's used for files and different programs. Programs would be things like the as discussed before, the 3D graphing software, and like an equation solver. The calculator has this feature, the equation solver, where it can like solve equations on its own, kind of, and other such programs. That's what the NAND flash memory is used for. The TI-nSpire CX Calculator has 128 megabytes of NAND flash memory. Then now we'll discuss the second memory that's used in this device, and that is the SD-RAM. SD-RAM stands for Synchronous Dynamic Random Access Memory. So yeah, SD-RAM. Now this memory is used for it's for things that are a little less complex, just like calculations. Though calculations can be complex, it's not, that this memory is like in basic form of memory. It's still pretty advanced nonetheless, you know. But it can be used for various calculations and even graphs. It can graph various things and stuff like that. So yeah, and the calculator has 64 megabytes of SD-RAM memory. And then the third and final memory component that is used for this calculator is the NOR flash memory. And then this is a more I'd say like a more basic form of memory, kind of. Not really, but kind of, because it doesn't have as much of a wide range of features. It just has one feature pretty much. It's only used when to power the calculator when you turn it on. So when you press the on button, then this memory gets used. The NOR flash memory only helps to power the calculator. It doesn't really do anything else much other than that. So that's all for that. Now I'll discuss some additional technical information about this calculator and then get deeper into the design of the calculator itself. I'll also discuss a challenge in the design of these calculators and then try to find a few solutions to them. And I'll discuss which is best and which are used in what situation, all of that. So, so now I'll discuss power consumption. So the battery that's used in the TI-nSpire CX is a lithium-ion battery. Another feature, it's sort of a feature. It's also part of the design of this calculator. And it has like a special circuit that helps. It doesn't. The circuit helps reduce less power consumption. Helps use up less energy. And the way it does this is because it distributes, the power to all parts of the calculator, and therefore each part of each component of the calculator uses some power, consumes some power, but not so much. Because if it were to do the opposite, if it just some power were consumed at only one part of the circuit, then there would be too much power consumed. But this method helps reduce power consumption. And it doesn't just reduce power consumption, but it also increases the life of the battery and increases battery life as well. That's also a significant part. This calculator is like more of a fun feature, kind of. The calculator can function for weeks. It can function for a few days, maybe a week or two, and its battery doesn't die out because this is the TI-nSpire CX is an advanced calculator and it can handle complex tasks. So it can be able to do these things, such as its battery having very high life, sort of thing. The chip for this calculator. So there are these things called ASICs. They stand for application specific integrated circuits, and it's in the chips for this calculator. And what that does, it also helps improve power consumption in a way, differently than as we've discussed before, what it does is it also, as you can see here, it says it reduces power consumption. It does that, yeah, but it helps like store the data as well in the chip of the calculator. So yeah, and now I'll discuss the challenge. So the challenge is this. The goal is to design a power control system that is able to perform advanced operations for the CPU while at the same time does not use up too much energy to the point that the device battery runs out of energy. So basically, we have to make like a power control system that can perform advanced features and operations while at the same time not using too much energy, and the battery life has to be still significantly, the battery life can't significantly deplete either. This is what I would call a low power high performance task, because there has to be low power consumption, but the calculator has to also function at high performance and a high level. So I call it a low power high performance task. Okay, so here I'll discuss a few of the possible solutions to this. So I'll discuss three possible solutions. First one is DVFS, the dynamic voltage and frequency scaling. So that's when a calculator on its own, it has like it's software. And the calculator has like a special software in it that can adjust the frequency of the CPU. And the reason this would be needed is because when there's an easy task, the calculator adjusts the CPU's frequency to be lower, and therefore less power gets consumed, and vice versa. You get the point there. So that's pretty good, pretty much, but it has a few challenges. So here I discuss the pros and the cons of this method. The pros are that it uses up power only when it's needed to use up power. However, the cons, and it's quite a big one, is that it requires energy. It requires advanced software to achieve this feature, so there's a lot of software needed to achieve this. There's also the multi-core architecture with asymmetric processing. This is basically when there are two cores, and it's kind of like the first method, but it's a little bit different because there are two cores. Normally there's one core, but here there are two. So there are two cores, and one that performs easy tasks, the other that does the hard tasks. Whenever there's an easy task, the easy core is used. A hard task, the hard one is used. And the hard one, however, uses up more energy, more power, while the easy one does not. The pros are that there's the right core is used for the right situation. When an easy task, an easy core is used. That kind of thing. However, the cons are that it has more advanced hardware. You see, there's two cores, not one, and it's more difficult to design. These cores are not easy to design, and there's two of them, so that makes it a little bit more difficult, kind of. And there's the third method that I'll discuss, and that is the algorithmic and software optimization. This is like a software solution, not at all really hardware. It doesn't really have any hardware connections to it. It's only purely software. This is the algorithmic and software optimization. It refers to rewriting the code, and rewriting it in a way that the program itself of the calculator can use can adjust its performance on its own, essentially. So yeah, and the coding language that's used for this is C. The pros of this are that it doesn't make the hardware more